by saying that that LangChain is a framework. So we say that LangChain is a Python framework that is basically used for building AI-powered application. And I think that's why we're here. We want to be AI engineers that are able to develop applications that are powered using AI. And for us to do that one, we need a framework. So we need a way to do that one. And that's why we are talking about LangChain. Very, very popular out there. Most companies are using it for building their enterprise AI applications. So I'm looking for a very good images. This is the one. This could be one that I normally prefer images. They communicate louder than text. Yes, now I think I'm good. Perfect. So in our previous session, we were using this document to understand the philosophy of LangChain. If we want to start building AI-powered applications using LangChain, what do we need? What is the philosophy behind it? Okay, so we had talked about the philosophy. Actually, we talked about composability, where we were saying that if you're building AI-powered application, then you start small, focusing on components that can be combined to create complex behavior. We're going to see that one in development. We also mentioned about modularity in such a way that each component should have a clear responsibility, standardization, and so on and so forth. So we also saw an overview of the LangChain architecture, okay? So if you could recall, this is what we were talking about actually, that for us to work with LangChain, there are some components that we have within LangChain. So I think this image is clearly communicating what we are talking about. This image, I hope you're able to see it. So the LangChain is the entire framework. LangChain is the entire framework that people are using to build their AI-powered applications out there. And the key components within LangChain is LLMs. So LLMs of building AI-powered application, we need them. So if you want to ask yourself, what are these LLMs? Then I think I also have a very good images to demonstrate LLMs here. So these are the LLMs. They are applications that were built either by using pre-training, embeddings, tokenization, and transfer learning. So in other words, I think we had mentioned here that using vast amount of data. So that is all the information we have in the internet. It has I think we had talked about this one. They were first tokenized. So in such a way that they were broken down into smaller modules that we call tokens. Then they were converted into numerical representation. That is what we call embeddings. And then out from there, using attention mechanism, I think we mentioned about it, using attention mechanism, we were able to build this large language model. Now, to add more information to these already existing large language models, some people are still doing what we call pre-training. Oh, sorry, not pre-training, but transfer learning. So you are adapting this LLM to more information, okay? So these are the large language models that we have. And if you can see from the diagram, I was showcasing varieties of large language models from premium-based ones hosted on Hugging Face. Now, important, I think we talked about them, and we said that prompts are the way to interact with these large language models. They act as instructions, okay? And for us to write effective instruction to these LLMs, then we had actually discussed something called prompt engineering. So we had talked about few short prompting. We had talked about role-based prompting, where you're giving it personalities and so on and so forth. The third component that I think we left it were the chains. The chains. And this is actually where the name LangChain comes from. In such a way that now we can connect different components within this AI system to come up with a very complex AI application. I think that is where we are. So today I wanted us to proceed. We talk about indexing and document splitters or document loaders. We are going to see how they are used to add more information. We are going to mention about, not agent, sorry. We are going to mention about vector storage. So we're going to see that this information that you're feeding into AI system can be added into vector storages. So now using retrievers, we're able to get information from this vector storage. And then finally, we're also going to talk about agents. And with that one, we'll be having the foundation of LangChain. So we are going to add on this one using our code and showcase how we can now come up with this AI-powered application. So right back into it, we had mentioned about the core components like LLMs. I think I've talked about it now. Then from there, I've talked about prompts, where we had talked about prompt template. Okay. Then from there, I've also talked about chains. Yes, I've talked about chains. So in our previous linear, sequential. So these are the simple chains. Then from simple chains, you also have sequential chains in such a way that they can pass output from one step as input to the next step. We also have router chains. And I think we saw this is very, very useful. And most of the time, if you're using router chains, we use a library called, was it LangGraph? Yes, it was LangGraph, yes. So LangGraph can have router chains in such a way that it can basically, it can dynamically a customer support has a query. So that query can be passed to different departments. So we need a router chain to do that one. It can route it to finance, it can route it to marketing, and so on and so forth. And then we also have transform chains in such a way that they can apply data transformation between different LLM calls. So I think we are we want to build stateful LLMs, stateful AI-powered application. So by default, I think we mentioned that these large language models, they are stateless in such a way that they cannot remember the previous conversations that we have with them. So they cannot recall that one. But with the memory feature, and store and retrieve conversation history or relevant information in such a way that it enables contextual conversations and personalized interaction. If you're building your own personal assistant, then you need a memory so that we don't repeat on we don't repeat inputs to this application. Like, let's say you have a person know your meeting times, it has to know the projects you're working on, so that you don't have to repeat all this information every time you are using this LLM. So you're going to see how memory is very, very key in building this AI-powered application. And a very good example of memory that we have is the vector storage. So today I wanted us to start from indexes and retrievers. And this will be very, very key, especially when we are exposing these large language models AI-powered application into our existing system. If your company right now have information to do with your customers, you have information to do with your company policies, this external data, if you want to first. And this is the process that we call retrieval augmented generation. So if someone has time, so if you're in that capacity, maybe you can research for us what is RAG. Maybe someone can research for us what is a RAG system. And by us understanding RAG system, we're able to understand why indexes and retrievers are very, very key in actually working with external information, okay? So if you check my notes here, it is one of the most powerful capabilities that LangChain has, because it enables these large language models to work with the existing data and so on and so forth. So therefore, if you think that one, it means that indexes and retrievers allows you to efficiently search through LLM. So if you're saying that we are providing data to this AI, then we need a way to search through information and provide the most relevant content to the LLM. So that is actually where we need indexes and retriever. I don't know that someone has found this RAG. I don't know that someone has researched for us RAG system. Okay. Because we are now seeing that if we are able to work with indexes and retrievers, then this is the foundation of building RAG systems, okay? RAG systems. So we have document loaders, okay? Document loaders. So remember, different companies already have information. If you check the government, the government, they have information. If you go to hospital, they are hosting large amount of information. Similarly, for us to pass this data into AI systems, we need document loaders. And document loaders, if you're seeing my notes, they have a capacity to import data from the various sources. So remember, even this AI system knows that our informations are stored either in PDFs, like our company policies, our missions, our objectives, our FAQs. Then some companies' information are stored on websites. Other companies store their information, like their customer details, on databases. And others, For example, if you're working with financial system, remember financial system, they are very, very critical with data. So they need a mechanism to provide data to other sources. So that's why they use APIs. So remember, if you're working with an API, then you must be verified. That is what I'm talking about. You must be verified so that you can now get those information. So with document loaders, I don't know whether if you find them, you can search different types of document loaders. We are able to provide this data to our AI system from PDF. We are allowing these AI systems to learn from our personal information. Remember, the LLMs that we are talking about here, they were trained with massive amount of information from the internet. So those information, they are not personal to us. So now we need document loaders to pass this kind of information. So we're going to see different types of document loaders. So there are document loaders to load PDFs. Others are used to load tables. Others are used to load websites. Other Another very key, yes, I think we have Shadrach. Yes, yes, thank you, Shadrach, there. So if you go to the comment, you can check the charts. The whole idea of indexing and retrievers is to build RAG systems. And if you check the comments right now, RAG, it's an AI architecture that combines information retrieval with text generation. So instead of just relying on what a language model knows, so if you're talking about GPT-5o, it knows a lot of things because it was fed with a lot of information. We can explicitly lie from training, whereby these LLMs can retrieve retrieved content. So that is very, very key if you're building different AI systems. For example, this company that was building systems like, I don't know whether I'm supposed to expose, like e-Sharia. So e-Sharia I don't want to go through that. Oh, thank you. Yes, so there's a company like e-Sharia. Yes, they, I think it's taking time to load. Their main focus was to expose these LLMs to our Kenyan legal context. So what they did, I think they exposed the Kenyan constitution, they exposed the previous rulings, and so on and so forth. So that now the AI system that they are calling e-Sharia, I don't know why it looks this way, the system that they are calling e-Sharia, it's able to learn from our Kenyan legal context. And that is why they used RAG. I think you also have another definition from Bugwa. Thank you, Bugwa. Looks like their system has some issues, but it's a very good system that we can use to demonstrate what we mean by retrieval augmented generation. According to Mbugwa, if you're seeing that one on the chart, we are being told that RAG systems are designed to enhance the capabilities of large language model. So this enhancement is working in such a way that they can retrieve APIs database, and then using this And so I think that's why I'm really emphasizing on these indexes and retrievers, because this is basically what we are going to do. We are going to have a knowledge base where we can provide different company information. Then now AI can accurately generate the information based on that knowledge base to avoid something we call hallucination. Research for us as we proceed, hallucination. Something called text splitter, so that it can now break down large document into smaller, manageable chunks. There is even a process called chunking in the context of AI, because vector stores, they are used to store document are actually the numerical representation of this information. Remember, computers works better with numbers, so they don't understand text. So in that context, we can convert this information into what we call embeddings. And then now using semantic search, we are able to retrieve relevant information. So there are different ways of storing data within a vector storage. I think we have Chroma DB, we have Pinecone, we have FAISS. I think it stands for Facebook. I think I've always remembered this abbreviation. I don't know why I forgot it today. Let me just confirm. Yes, it stands for Facebook AI Similarity Search. So it's able to retrieve. So these are the retrievers. It's able to retrieve relevant information from the knowledge base. And then you also have retrievers that is used to query data from vector stores and then return relevant document based on the similarities of your input. Okay. And then now, like I was explaining, embeddings semantic meaning. This is something you can research more about. But if you have an idea of building a legal document search system like e-Sharia, where lawyers can ask questions in a natural language, like for example, what are the penalties for breach of contracts in Kenya, not California? The system can search through thousands of case passages and synthesize your answers. So that's why indexing and retrievals is very, very key in this AI system. So we can move to the next one, which is actually the most interesting part of this course, agents. These are now what people want nowadays, agents and tools. So there is agents and there is tools. And if you can see there, if you are working with agents, then they have a capacity to autonomously make their own decision. So I have a diagram here to explain agents. And I don't know whether someone can research for us what is an AI agent. Then we can relate it with this diagram. This one here, this is an agent. I hope you're seeing that image. Agents. So anytime you're talking about agents, we are also talking about tools. our Gmails. It can work with our spreadsheets. It can build its own presentation and reports and so on and so forth. So an agent, if you're also researching for us, then we can compare with this one. Sorry. An agent is getting